All right, we're looking at a proportional table, and we need to find those missing values in the table A, B, and C. Because I know the table is proportional, I know a couple things. I know that the table runs through the point 0, 0, the origin. I also know that it is linear, straight line. And because it's linear and it's proportional, I know that when I compare G to H ratios in the table, or I take all the H values, I compare them to G, the reciprocal, that these unit rates, or these, sorry, this rate will be equivalent for the entire table. Or if I flip it over, this ratio here will be the same for the entire table. I also know that they all have the same unit rate. So if I take these fractions and compute the unit rates on them, or unit ratio on them, it's the same for each one when I do that. So I'm going to look for information in the table that will help me understand this relationship, G to H or H to G. I'm going to use H to G because when I have proportional tables, a lot of times I'm looking for the constant of proportionality, which is called the K value. So when I look, I have two of the numbers, H and G, so I'm going to write -6 over -4. And that's going to give me a big clue about the table. So how do these compare? Well, when I get down to the unit rate, I realize that if I divide by -4 in the bottom to get that unit 1, I'll do that in the top as well, and I get 1.5. My negatives go away. So that tells me that my Y value, or in this case G is 1.5 times bigger than X, or in this case, sorry, I said that backwards. H, I'm doing H over G. Got to keep those letters, might be helpful to do this. I'm comparing H to G here. H is 1.5 times bigger than G. So this number is always going to be larger by 1.5 times larger. So if I want to find my A value, I'm going to divide it by 1.5. So because I'm going backwards, I'm going from H to G. This one is 1.5 times bigger, so this we have to divide inverse ops. If I want to find my value for B here, I'm going to divide 18 by 1.5 because I'm going backwards in my table. Here I'm going forwards. This number has to be 1.5 times bigger. So I'm going to multiply 24 times 1.5. You may not have worked it out that way. You could have just taken the ratio -6 to -4 and set up equivalent fractions with your missing values. So I did H to G again. That's just because it's my habit. I like to do the dependent over the independent. And if I do that, then it's 3 to A. And you could say, hey, what did I divide -6 by to get to 3? We divided by -2. So I have to divide that by -2, and I get A equals 2. So you could have set up that way, found your equivalent fractions, or 18 over B equals -6 over -4. Okay, so how do I get from a -6 to a positive 18? I multiply it by -3. Got to do the same to the bottom, multiply it by -3, and you can get your 12 there. And one more. We've got 24 over C. Whoop, I'm going to go the other way. I don't want to switch it on you now. H over G. And H over G again, -6 over -4. And how do we go from a -4 to a positive 24, we multiply it by negative 6. How do we go from a negative 6? We got to also, to C, we got to multiply it by negative 6, and we get that 36 right there. So you can set up equivalent fractions, or you can find the relationship, which is that this is always 1.5 times bigger than G. That's the equation. And that's it.